Chapter 10.1, Use Properties of Tangents. Okay, a circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. A circle with center P is called circle P, all right, and it can be written like this. You draw the circle symbol with a dot in the middle and then the capital letter that represents the center. All right, so if you see this symbol followed by the letter P, you know that P is the center. A segment whose endpoints are the center and any point on the circle is a radius. And a chord is a segment whose endpoints are on a circle. A diameter is a chord that contains the center of the circle. Okay, let's look at the diagram. Okay, notice the radius here in red. I'll draw over it in red here. See the radius, it starts at the center and it goes to the circle itself. Okay, you can draw the radius in any direction. It's always the same length as long as you start at the center and go to the circle itself. That is a radius. All right, now for the chord, it's a segment whose endpoints are on the circle. See the chord here in green, and the endpoint is right here and right here. So a chord does not have to go through the center of the circle. It just is a segment whose endpoints are on the circle. And then finally, the diameter is the same as a chord, except the diameter goes through the center. All right, see the diameter here goes right through the center. And again, its endpoints are on the circle itself. All right, and just for your information, we've covered this before. The radius is always going to be half the diameter for any given circle. Okay, a secant is a line that intersects a circle in 2 points. A tangent is a line in the plane of a circle that intersects the circle in exactly 1 point, the point of tangency. The tangent ray AB and the tangent segment AB are also called tangents. Let's take a look. So the secant here, it's slightly different than a chord because a chord is only a line segment. A chord will stop on the circle, all right? But the secant is not just a segment. A secant is a line, okay? And it intersects the circle at 2 points. So the secant hits the circle at 2 points, but it has to be a line, all right? And a tangent line hits the circle at only 1 point. Okay, you see right here, this point B, where it hits the circle, that's called the point of tangency. All right, and this blue line here, BA, is a tangent line. All right, it really, you can say that, you can say tangent ray AB, and you can say segment AB are also called tangents, all right? But really, they have to be part of a line because you can't draw a line segment and stop at the circle and say, well, that's just 1 point, so it's a tangent line. It has to be a continuous line that keeps going and hits the circle at only 1 point. Example 1, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. All right, let's take a look. First up is line segment AC. So let's take a look. All right, if we look at line segment AC, that's this right here, and that is a radius. Okay, so part A is going to be radius. That's for AC. Part B, we're looking at segment AB. Okay, segment AB, here's A, here's B. It travels from one end of the circle to the other, but it goes through the center. Okay, so that's a diameter for part B. That is a diameter for segment AB. Now we're looking at ray DE, and D is the endpoint of the ray. Okay, so if we start at D, the endpoint is the starting point, and we head toward E, and it continues forever. We can see it hits the circle at one point, so that is a tangent. Or you can say tangent ray. Okay, and that is for ray DE. And then finally, line AE. Okay, so here's point A, here's point E. And this line, AE, it intersects the circle at 2 points. So that is a secant. Answer D is a secant. And that is for line AE. All right, guided practice 1 and example 1. What word best describes AG and CB? Let's take a look. All right, see if you can figure out segment AG and CB. All right, if you look at AG, there's a point here and a point here, and it is just a segment. Okay, the endpoints are on the circle, so that is considered a chord. All right, for segment CB, the center is at C, the endpoint is on the circle, and this segment right here is a radius. In example 1, name a tangent and a tangent segment. So I'll give you a hint. The tangent is going to be a line. Okay, so name a tangent line and a tangent segment. All right, think about that for a moment. Tangent line and tangent segment. All right, for the line, that would simply be DE. Okay, so you use 2 letters, DE, with the line symbol on top with the 2 arrows. All right, and for tangent segment, you can say the same thing, DE, with just a bar on top. Okay, so this would be the tangent line, and this would be the tangent segment. The segment, of course, is a part of the same line. All right, the words radius and diameter are used for lengths as well as segments. For a given circle, think of a radius and a diameter as segments, and the radius and the diameter as lengths. All right, example 2, use the diagram to find the given lengths. So let's see if we can find the radius and diameter of circle A. Let's take a look. Okay, so it's very easy. The radius just go from the center to the circle itself. And if we counted units, 1, 2, 3. Okay, so the radius equals 3. And if we were to do the diameter, it would be 3 here plus 4, 5, 6. Okay, so the diameter equals 6. All right. So we already know the radius just goes from the center to the circle, and the diameter goes all the way through from one end of the circle to the other end and through the center. All right, radius and diameter of B. So we see circle B, the radius goes from here to here. That's 1, 2 units. So the radius is 2, and of course, if you just double that, 3, 4, the diameter goes all the way through. The diameter equals 4. All right, see if you can do the diameter for circle C and the radius. All right, if you start at the center, the radius would just be 1, 2, 3 units. So R equals 3. Double that, and you get D equals 6. Here's 3, 4, 5, 6. Pretty easy. All right, so coplanar circles. 2 circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. All right, and coplanar circles that have a common center are called concentric. So let's take a look. So here, these circles that are coplanar, they have 2 points of intersection. All right, so here, here, and here, here. 2 points each. Now, if the circles intersect at 1 point, those are called tangent circles. All right, so see these 2 circles intersect at the 1 point. They're next to each other. Here we have one inside the other, but nevertheless, they intersect at 1 point. So these are tangent circles. All right, no points of intersection. Right here, the 2 circles are separate. And when the 2 circles have the same center, those are called concentric circles. All right, so that just means same center. All right, a line, ray, or segment that is tangent to 2 coplanar circles is called a common tangent. So you see this line here in blue. It intersects this circle at 1 point, and this circle at 1 point. It is tangent to both circles, so that is called a common tangent. Okay, in this case, the circles are separate. And, well, actually, that's both cases. All right, same here. The blue line intersects the circle at 1 point here, 1 point here. It is a common tangent to both circles. Okay, example 3. Tell how many common tangents the circles have, and draw them. All right, so I think in part A, we can draw one like this, and then we can draw another X like that. Okay, so I think A has 2. I'll check the answer in a minute. If you look at B, these circles are next to each other, so it has to be one line, and I drew it crooked, but one line right through the center. So I think this is just 1. And answer C, problem C, I could draw one like that, and I can draw one like that, and I think that's it, so I'm going to say 2. All right, so let's check the answers for part A. A is actually 4. Okay, I missed 2 of them. So there's going to be one more right here and one more right there. Okay, so it's not 2, it's actually 4. All right, there you go. So the X shape and one on the top and the bottom. Answer B, I got that one wrong. I forgot the one on the top and bottom. So there was one here and there was one here. All right, so it's not 1, it's actually 3. And then finally, answer C, I got that one correct. The ones on the top and bottom, there's 2 tangents. All right, so this one had 2, this one had 3, and this one had 4. All right, try guided practice number 4. Tell how many common tangents the circles have. All right, so number 4, I'm thinking one here on top and one here on the bottom. Okay, nothing in the middle. So that's going to be 2. All right, and that matches this one right here. All right, try number 5. Please tell how many common tangents. All right, I'm thinking this right here is the only one. Okay, can't draw anything on the top and bottom or inside the circle. It can't go inside. So I think it's just 1. Okay, there's nothing like this in the previous example. So I'm pretty sure it's just 1. All right, please try number 6. I think number 6 is 0. There is no line that you can draw that is tangent to both circles. It's impossible. So no matter where you draw the line, it won't work. So that one is 0 as far as I know. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. All right, so this red segment here is the radius, okay? That's a radius. And this tangent line at the endpoint of the radius is where it intersects, okay? So P is the endpoint of the radius, and it is also the point of tangency. And what they're saying is that tangent line is perpendicular to the radius. Okay, so the only way that line M can be a tangent line if line M is perpendicular to QP. Example 4, in the diagram, PT is a radius of circle P. Is ST tangent to circle P? Let's see. Okay, they're asking us, is this right here tangent to circle P? So they're asking, is ST a tangent? Okay, that's what they're asking. Well, this is the radius right here. Okay, because they said circle P, so P is the center. So it has to be perpendicular right here. So asking if ST is tangent is the same as asking if ST is perpendicular to TP. All right, that's basically what they're asking. Perpendicular means it makes a right angle. So we want to prove that this is a right angle. Okay, so in other words, they are just asking, in this case, is A squared plus B squared equal to C squared? Okay, because that's the only way to prove this is a right triangle. All right, so across from the supposed right angle is the hypotenuse, that's C. The other two sides, it doesn't matter which is A or B. So I'll let A equal 35 and I'll let B equal 12. So A squared is going to be 35 squared. B squared is going to be 12 squared. And C squared is going to be 37 squared. All right, we don't know if this is true yet, so I'll put a question mark there. And I'm going to try to prove that on the calculator. I'll just do it all in one shot. 35 squared plus 12 squared equals 1,369. 1,369. And on the other side, 37 squared definitely equals 1,369. Okay, I did both of these on the calculator. So the answer to this question is yes. Okay, that proves that this line here is a tangent line. So the answer is yes. Or you can say a tangent segment. Example 5, in the diagram, B is a point of tangency. Find the radius R of circle C. Okay, so it's given that B is point of tangency. All right, that's given. That means AB is tangent to the circle. And they did say circle C. Okay, so we know that C is the center. Okay, plus they wrote the letter R here, so we know that these are both radiuses. All right, so since B is the point of tangency, this is a tangent line here, and this is going to be a right angle right here. All right, so we need Pythagorean theorem. Now, this segment here in blue is 50, and this radius here is considered R. So if we took the side length of that whole side, it is going to be 50 plus R. All right, so we're still using Pythagorean theorem. A squared plus B squared equals C squared. Okay, and across from your right angle is the value for C. So this whole side is C, and C is going to equal 50 plus R. Okay, A and B, it doesn't matter. They're just the other side, so I'm going to let A equal 80, and I'm going to let B equal R. All right, so this is B, this side length is A, and this side length is C. Now we can plug in A squared is going to be 80 squared. B squared is going to be R squared. And C squared is going to be 50 plus R. All right, so you need to use parentheses because C is 50 plus R. And that whole thing is squared. All right. Now, in order to unpack this here, we have to use FOIL or distribute. So 50 plus R squared, if I can erase that squared, 50 plus R squared is the same as 50 plus R times 50 plus R. All right. So 80 squared, 8 times 8 is 64, and you just add 2 zeros, plus R squared. Okay, you can distribute or use FOIL. 50 times 50, 5 times 5 is 25, and I'm going to add 2 zeros. 50 times R is 50R. Distributing the other term, R times 50 is 50R. And I'm almost out of room. Finally, R times R is going to be R squared. Let me make more room. Okay, the last term here is plus R squared. All right. Now, this is not as bad as it looks because we can easily get rid of R squared on both sides. All right. So since we have plus R squared on both sides, I'm going to do the opposite and do minus R squared on both sides. Okay, R squared minus R squared is 0. R squared minus R squared is 0. So I'm going to bring down 6,400. I'm going to bring down the equal sign. I'm going to bring down 2,500. And combining 50R plus 50R, that's going to be positive 100R. All right, we want variables on one side and numbers on the other. The opposite of positive 2,500 is negative 2,500. So I do that to both sides. 25 minus 25 is 0. Bring down my 100R. Bring down my equal sign. And this is going to be, let's see, 14 minus 5 is 9. And 5 minus 2 is 3. So 3,900. This is 100 times r. The opposite of times 100 is divided by 100. Okay, it cancels here. And divide by 100, you just drop the 2 zeros. So 3,900 becomes 39. And that is my radius. And the units were in feet. So that's the only thing I forgot. It's 39 feet. Okay, tangent segments from a common external point are congruent. So here it says if SR and ST are tangent segments, then SR is congruent to ST. All right, so first it has to be established that these are tangent segments. And since they come from the same point, since they have the same endpoint outside the circle, they're both sharing point S, that means they are congruent. So this length is the same as that length because they both have the same endpoint outside the circle and they are both tangent. Example 6, RS is tangent to circle C at S, and RT is tangent to circle C at T. Find the value of X. All right, they said this segment here is tangent at point S, and this segment here is tangent at point T. They both share point R outside the circle, so that means these line segments are congruent. All right, so RS equals RT. Let's start with that. RS equals RT. And it is given in the problem and in the diagram, RS equals 28. And RT is this one right here. That's 3x plus 4. So you just set them equal. All right. Variables on one side, we want to get rid of positive 4. The opposite is negative 4. 4 minus 4 is 0. 28 minus 4 is 24. Bring down your 3x. The opposite of times 3 is divided by 3. Cancels there. 24 divided by 3 is just 8. All right, so let's see. They only asked us to find the value of x, so that was it. All right, if you wanted to check, you would take the 8 and just plug it in right there. 3 times 8 is 24, plus 4 is 28. So it checks out. Okay, number 7, guided practice is DE tangent to circle C. So if this is the tangent here, and circle C means C is the center, this is going to be the radius. So the radius and the tangent make a right angle. See if, let me see if you can prove that, and I'll give you a hint. If the radius right here equals 3, then the radius right here is also going to be 3, and this entire side is going to be 3 plus 2, which equals 5. So see if you can prove that's a right triangle. All right, so basically, we're just doing a squared plus b squared equals c squared. All right, go across from your right angle. That's your hypotenuse, and we said 3 plus 2 is 5, so that's going to be c. A and b are the other side, so I'll let 4 equal a. I will let 3 equal b. All right, so for a squared, that's going to be 4 squared. For b squared, that's going to be 3 squared. And for c squared, that's going to be 5 squared. All right, you can use your calculator, but 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, and 5 squared is 25. So it checks out. All right, so the answer is yes. All right, number 8, it's given that ST is tangent to circle Q. All right, find the value of r. Again, I'll give you a hint. If this is the tangent and this is the radius, the right angle is going to be right here. All right, and we said this side length is going to be r plus 18. So see if you can solve for r. All right, once again, Pythagorean theorem on this right triangle. You go across from your right angle, and that entire side length is your hypotenuse. So that has to be the value for C. All right, this whole thing is C. The other two sides, A and B, it doesn't matter. I'm going to let A equal R, and I'm going to let B equal 24. So A squared is going to be R squared. B squared is going to be 24 squared. And C squared is going to be R plus 18 quantity squared. So you need to use parentheses on the R plus 18 since that's squared. All right, now once again, R plus 18 squared is the same as R plus 18 times R plus 18. All right, so you need to use FOIL or distribute. Over here, R squared, 24 squared is going to be 576. Distribute, R times R is R squared. All right, R times 18 is 18R. Distribute the other one. 18 times R is 18R. And finally, 18 times 18, I'll just do 18 squared on the calculator, and I get positive 324. All right, just like last time, we have an R squared on both sides. So I am going to do minus R squared on both sides, the opposite, in order to get rid of it. R squared minus R squared is 0 in both cases. Bring down 576. Bring down the equal sign. 18R plus 18R is going to be 36R. And we still have 324. You want to bring that down. All right, so I just combined the like terms and got rid of the R squared. Now I want variables on one side and numbers on the other. So I'm going to do minus 324 on both sides. Cancels here. Bring down the 36R. Bring down the equals. 6 minus 4 is 2. 7 minus 2 is 5. 5 minus 3 is 2. This is R times 36. The opposite is dividing by 36. You want to do that to both sides. And it cancels here. 252 divided by 36 gives us 7. So R equals 7. All right, and that's all they asked for. Find the value of R. All right, last one, try number 9, find the values of X. And I'll give you a hint, since these are right angles here, that means these line segments are both tangent to circle P. And they have the same endpoint outside the circle, so X squared and 9 are equal to each other. So set them equal to each other and solve. All right, they have the same point outside the circle. They make the right angle, so they're tangent segments. X squared equals 9. And the opposite of squaring something is to take the square root. So you want to do square root of both sides. And X is going to equal plus or minus 3. All right, remember when you do the square root of both sides, you need plus or minus. And the reason that is because if you plug in -3 and you square it, -3 times -3 equals 9. So it's both positive and -3. I understand a side length cannot be negative, but the side length is not x. The side length is x squared. So once you square it, it becomes positive. So both of these answers work.